Welcome back. So far, we've explored your journey into cloud and edge systems engineering and uncovered what the industry is really like behind the scenes. Now it's time for what many listeners look forward to the most: real stories from the field. Every engineer has projects they'll always be proud of, and projects they'll never forget because of the lessons they taught. Let's begin with a project that almost failed.
I think every cloud and edge engineer has at least one story like this. A few years ago, one of our customers wanted to modernize their manufacturing platform. They had hundreds of industrial machines spread across multiple plants. Their goal was to collect real time sensor data from every machine, process critical events immediately at the factory, and analyze long term trends in the cloud. It sounded like the perfect cloud and edge project. We designed edge gateways for local processing, a cloud platform for centralized analytics, and real time dashboards for management. The architecture looked excellent, the testing environment worked perfectly. Then we deployed the system. Within the first day, the dashboard started showing missing sensor data from one of the factories.
That must have caused quite a bit of concern. What went wrong?
At first, everyone suspected the cloud platform. Then someone blamed the edge software. Others thought the industrial IoT sensors were failing. After several hours of investigation, we discovered the real issue. The network connection between the factory and the cloud was unstable. Our design assumed continuous connectivity. Reality didn't. Whenever the connection dropped, some data couldn't be transmitted immediately. The lesson was clear. In cloud and edge systems, you must always design for unreliable networks. Edge devices should continue operating independently and synchronize data automatically once connectivity returns. That experience completely changed how we design distributed systems.
So, the biggest problem wasn't software, it was assuming perfect network conditions.
Exactly. One of the first lessons every cloud and edge engineer learns is this: never assume the network is always available. Distributed systems must expect interruptions and recover gracefully.
Tell us about another project that changed the way you think.
One customer wanted to migrate a large industrial application to a cloud native platform. They expected the migration to be quick because the application already worked well on their local servers. We simply packaged everything into containers and deployed it to Kubernetes. Technically, the deployment succeeded, but users immediately reported poor performance. The application wasn't designed as independent services, everything depended on everything else. Running it inside containers didn't magically make it cloud native. We had to redesign the application into smaller microservices before we saw the scalability and resilience we expected. That project taught us that cloud native architecture is a design philosophy, not just a deployment method.
That's an important distinction. Many people think moving to the cloud automatically modernizes an application.
Exactly. Technology alone rarely solves architectural problems. Good architecture comes first. The cloud simply enables it to perform at scale.
Let's talk about the most unusual bug you've ever encountered.
This one became legendary inside our company. We had deployed several edge devices across a production facility. Everything worked perfectly during the day. Every night, around the same time, one edge device disconnected from the cloud. It reconnected automatically after about 15 minutes. The log showed no obvious software errors. We checked the network, nothing unusual. We replaced the hardware. The problem continued. Eventually, an experienced maintenance engineer solved the mystery. Every evening, the facility automatically switched electrical power to a backup circuit for scheduled maintenance testing. The brief voltage fluctuation caused the network switch serving that area to restart. The edge device wasn't failing, it was simply losing network connectivity for a short period. We redesigned the communication logic to queue data locally until the connection returned. That bug reminded us that cloud and edge engineers often solve physical infrastructure problems, not just software problems.
That's fascinating. It really shows how closely software and hardware are connected in industrial environments.
Absolutely. Cloud and edge systems engineering exists at the intersection of software, networking, infrastructure, and industrial operations. Understanding only one of those areas isn't enough.
What's the biggest engineering mistake you've personally made?
Early in my career, I became obsessed with maximizing cloud scalability. I designed an architecture capable of handling millions of requests every day. It was technically impressive. Then the customer asked a simple question: can it continue operating if our factory loses internet connectivity? The answer was no. I had optimized everything for cloud performance while completely overlooking edge resilience. That project taught me that availability is often more valuable than maximum scalability. Today, whenever we design systems, we ask, what happens if the cloud becomes temporarily unavailable? If the answer is everything stops, we redesign the system.
That's a lesson every distributed systems engineer should remember.
Exactly. Cloud is powerful, edge is resilient. The base solutions combine both.
Tell us about your most challenging customer.
One manufacturing company wanted real time dashboards updating every second from thousands of machines. At the same time, they wanted to minimize bandwidth costs. Those goals conflicted with each other. Instead of sending every sensor reading to the cloud, we introduced Edge Analytics. The Edge devices filtered unnecessary information, summarized routine events, and transmitted only meaningful insights. Bandwidth usage dropped dramatically while managers still received the information they needed. That project reinforced an important engineering principle. Sometimes the smartest solution is deciding what not to send.
That's an excellent point. Good engineering isn't always about collecting more data. It's about collecting the right data.
Exactly. Modern systems generate enormous volumes of information. Engineers create value by transforming raw data into useful decisions.
Have you ever had a Kubernetes deployment that caused unexpected problems?
More than once. One memorable deployment involved a microservice responsible for processing industrial IoT messages. Everything worked perfectly under normal traffic. During a factory wide equipment test, message volume suddenly increased nearly tenfold. Our Kubernetes cluster automatically created additional container replicas. That part worked exactly as designed. The problem was our database. It couldn't handle the sudden increase in simultaneous requests. Scaling one part of the system exposed another bottleneck. We optimized database connections, introduced message queues, and redesigned the architecture. That experience taught us that scalability applies to the entire system, not just individual services.
After years in this field, do projects still surprise you?
Every project does. Every customer has different priorities. Every factory has different infrastructure. Every network behaves differently. Every edge deployment introduces unique constraints. That's one reason cloud and edge systems engineering remains so exciting. Technology continues evolving, and every deployment teaches you something new.
Before we wrap up, could you summarize your philosophy in one sentence?
I'd say this: successful cloud and edge systems aren't built by chasing the newest technology. They're built by designing reliable systems that continue delivering value even when something unexpected happens.
That's a perfect way to conclude today's stories. We've learned that successful cloud and edge systems engineering isn't just about cloud platforms or edge devices. It's about designing resilient architectures, preparing for network failures, building scalable applications, understanding industrial environments, and solving real operational problems. In our next segment, we'll spend a day with a cloud and edge system startup founder. We'll follow your schedule from morning infrastructure monitoring and deployment reviews to cloud architecture meetings, edge device testing, DevOps pipelines, customer discussions, and production operations. Stay with us.